The composite materials that make up this aircraft, they're as strong as the traditional materials, and they're as flexible as the traditional materials as well. To give an example of how sturdy they are, there's more than 1 ton of air pushed inside this aircraft when it's flying, when it's pressurized.
The use of glare reduced the overall weight of the A380 by 15 tons, allowing this massive plane to be light enough to fly.
If they hadn't used glare or a similar composite, the aircraft that we have today probably wouldn't exist.
The A380 may be able to fly, but its ideal wingspan is too large for the world's airports. So designers had to take a classic engineering solution.
Often in engineering, the simple solutions are the best solutions.
And give it a 21st century twist. The Airbus A380 is a triumph of 21st century aerospace engineering. It's the largest commercial airliner in operation today. At a state-of-the-art custom-built hangar in Paris, this A380 is undergoing its scheduled 4-year service, giving technicians a chance to get intimate with this colossal machine.
It's a big aircraft. You cannot imagine that it's going to go and fly so easily.
It's not just the materials on the A380 that make it stand out from the crowd. Even the method of construction is groundbreaking. Sections of the A380 are built in France, Germany, the UK, and Spain, then transported to Toulouse for assembly. Moving these parts requires custom-built ships and the use of Airbus's A300-600 ST Beluga supertransporter plane. Each A380 contains 4 million individual parts, which, once assembled, create an airliner of record-breaking proportions.
I guess this aircraft makes everybody dream when you see it. When people are waiting to go inside the aircraft, you can see children looking at it. People are really excited.
The ideal, most efficient wingspan for this massive aircraft is 270 feet. But aviation regulations state that all planes must be able to fit into a 262-foot box. If engineers didn't come up with a way to shrink the A380's wings, it would be too large for the world's airports. Their solution was found in a great aircraft innovation from the 1970s. In 1973, the world was in an oil crisis. An embargo on sales to the West saw prices quadruple overnight. The aviation industry was paying the price. A solution was desperately needed to improve airplane fuel efficiency. And aeronautical engineer Richard Whitcomb found one while working on NASA's Aircraft Energy Efficiency Program.
Aerodynamicists are always trying to improve the efficiency of wings, which really means trying to improve the ratio of the lift to the drag of the wing. One of the things that was causing a lot of drag and dropping the lift on the wing was what's called a wingtip vortex.
This wind tunnel is simulating an ordinary wing traveling through the air at a typical cruising speed.
In the central section of the wing, you can see that the smoke is very smooth until it reaches the tip of the wing. And once we're at the tip of the wing, you can see this vortex pattern forming.
A wingtip vortex occurs when high-pressure air under the wing spills upwards at the tip to meet low-pressure air above. This leads to turbulence and drag, forcing the engine to work harder. Richard Whitcomb's idea was to change the design of an aircraft's wingtips into vertical winglets. The winglets create less drag and burn less fuel.
As I move the smoke trace towards the end of the wing this time, instead of having the single strong vortex that we saw in the case without the winglets, what's happening now is that the flow is smearing out almost into a sheet, making the wing more efficient.
Adding a winglet prevents the mixing of the two airflows above and below the wing, reducing the vortex. The A380 has specially designed arrow-shaped winglets called wingtip fences. These allow the wings to be shortened to just under the maximum allowed 262 feet without compromising the aircraft's efficiency.
Without those design features, this aircraft would be way too big, it wouldn't be practical, and it wouldn't exist today.
The Airbus A380 is the largest passenger airplane in the world. It's equipped with some of the world's most powerful jet engines and has a skin made out of a cutting-edge lightweight composite. Specially designed winglets make it fuel efficient enough to travel almost 10,000 miles non-stop. But how is it possible that a human can steer a plane this large and powerful? By the 1960s, the age of the jumbo jet was in full swing. Transcontinental travel had never been easier or faster. But a group of audacious engineers believed it was possible to take a jet supersonic.
There were a lot of engineers who said, well, this isn't possible. What you're proposing here is just too ambitious. The result of the work of those pioneering engineers is this, Concorde.
Launched in 1969, the Concorde could reach speeds of over 1,200 miles per hour. That's more than twice the speed of sound. Flight times between New York and London were cut in half. But flying a supersonic jet would be impossible using traditional aircraft controls. Concorde needed an innovative new system, a system now known as fly-by-wire. Former Chief Concorde pilot Mike Bannister explains, using a simulator at Brooklyn's Air Museum.
You could fly at 1,350 miles an hour, faster than a rifle bullet. Concorde wouldn't have been possible without fly-by-wire because some of the control forces at certain flight conditions really would have been huge.
What exactly is fly-by-wire?
Fly-by-wire is computers telling systems what I want to do. On a conventional airplane, when I want to turn left, I do that, and some pulleys and wheels and cables move the controls. On this airplane, when I want to turn, I do that. It tells a computer that tells the controls what to do. That means the airplane's far more responsive, it can be far more efficient, and is capable of being flown by ordinary human beings.
Concorde was the first commercial jet to use fly-by-wire technology.
What did it feel like to fly the real Concorde?
The airplane's a delight to fly. It's like a thoroughbred racehorse rather than a riding school hack, or a sports car rather than a truck. It is so responsive. You can fly it with your fingertips, so why don't you have a go? Very nice. Keep it coming, that's perfect. Right through the bridge. London Assembly Building to the left, a Shard to the left. Fabulous.
Well, Concorde clearly is a remarkable aircraft. Not only is its exterior breathtakingly beautiful, but underneath the skin there is some technology that really revolutionized the aviation landscape and has made what we can do with modern aircraft today possible.
Since its first application on the Concorde, fly-by-wire systems have become industry standard. And on the Airbus A380, a highly sophisticated digital system makes flying the world's largest passenger plane possible.
For an aircraft this size, this aircraft is relatively a simple aircraft to operate. For flying, the aircraft is here, and it is completely electronic. I mean, there's no cables. It's all generating electrical inputs, which are sent to a computer, which then send the signal onto the flight control surfaces to move.
The design and development of the Airbus A380 ranks as one of the aviation industry's greatest achievements. Today, A380s are operated by airlines all over the world. One takes off and lands every 4 minutes. By drawing on the innovations of the past, adapting, improving them, and making groundbreaking innovations of their own. Aerospace engineers overcame extraordinary challenges and succeeded in making the impossible possible.
It was quite difficult to imagine 20 years ago that kind of machine you have here was going to exist, but it's now reality. So what about the future? Who knows? Maybe going to the space with an aircraft.